Hi everybody, we're going to have a quick look at the first derivative and finding it using differentiation. We've looked at first principles and we know we can find the gradient at a point, but what we'll find is that there are now some neat patterns that allow us to do it more quickly than using first principles. So by doing sufficient examples of by first principles, you should reveal that if y is some function ax to the power n, then the derivative is a(n)x to the power of n take 1. So literally what that means is take the power, multiply it by the coefficient, reduce the power by 1. So let's have a look at some examples. If we have y equals x squared, put the power out front. Oops, we don't need red, we need black. Put the power out the front, write down x, reduce the power by 1. So that would just be 2x. Multiply the power by the coefficient, so it would be 6, reduce the power by 1. The coefficient in this case is 1. Multiply that by the coefficient, which is also 1, so that would give us 1. Reduce the power by 1, so if the power is currently 1 and reduce it by 1, it would be 0, so x to the 0 would be 1. 1 times 1 would be 1. Actually, I'll write it here, x to the 0, which equals 1. So if you have x and you differentiate it, the variable is going to disappear. If you have any other power, it will do something. So here we go, we've got 42. We could write that as 42x to the 0, that would be 42 times 1, which would be 42. And that would allow us to use this idea up here. So times 42 by the power, so that would be 0. Reduce the power by 1. Anything multiplied by 0 is plain old 0. And that's true of any constant. Anytime you have a constant, you differentiate it, you'll end up with 0. This one's a little different. So over here I wrote 3 on x is equal to 3x to the minus 1. Multiply the power by the coefficient, that will give us negative 3. Reduce the power by 1, which will be negative 3 on x squared. Doing these manipulations are quite important because they allow us to do simplification later on. Now, we can do differentiation not just for equations, but also for expressions. We use this notation if that's going to be the case. So d by dx says differentiate whatever's next to it. If it was a longer expression, we might put a bracket around it to indicate what we're differentiating. So in this case, differentiate x squared, and we now know that that will just be 2x. Differentiate 3x to the power of 4, that would be 12x cubed. And over time, this will become quite a natural process. Now your graphics calculator can also differentiate, or your CAS calculator. So with this, we'll go down to the Maths 2 template, and it will allow us to produce this statement here. I might just remove it so that we do it together. Press the D on dx button, press X on your keyboard. So actually, the X that you'll see is this one over here. And over here, type what we're going to do. 4x squared. So 4, where's it gone? X. Use your caret symbol on your keyboard, squared, and it will find 8x for you. Magic. But it can do a little bit more than that. So if we wanted the instantaneous rate of change at x equals 4, we could take this statement here, pipe to it, x equals 4, and magically it will tell us 32. If we want to find the average rate of change when x equals 4, we could find what's that going to do? We would find the derivative. No, instantaneous rate of change when x, that's that one. If we wanted the average rate of change, we would have to find out the y value when x is 0. So stick that in. find out when it's 4, 64, subtract the y values from the, divide that by the difference in x values, and that would give us 16. Now it's all well and good with our calculator, but we should be able to do it on paper. So let's have a go at that. We know that the derivative of 4x squared is 8x. We can just do that on paper. We could let x equal 4, substitute that into the derivative, and find out the derivative is 32. That's easy enough. That would tell us the instantaneous rate of change at x equals 4 is 32. We could find the average rate of change. We need to sub in to this equation, not the derivative, don't make that mistake, 0 and 4, which we've done here. That gives us the change in y of the 2 points. The change in x is going to be the change in x values, so subtract those, find the difference, write them here, divide them, and that gives you the average rate of change. Now if you can do all of those processes, that's great. We're well on our way. Thank you, everyone.